The use of UUIDs within our naming structure for our disks and partitions is purely to give us a consistent device naming structure. We're looking in the demonstration here at, say, a disk that's called, or a partition that's called /dev/sdb1. Well, that's great. However, just because it's SDB1 now doesn't mean it's going to be SDB1 the next time the system boots. Let's say, for instance, that we're just working maybe not with SDB1, but let's just say with our first fixed drive. So that's going to be the fixed drive SDA. The first partition on that then is going to be SDA1. But if it's a laptop or even maybe a server that is set to search for USBs first, if somebody leaves a USB drive connected, although the USB drive is going to be SDB1 whilst the machine is powered on, during the boot phase, if we search for USB first, then that is going to become SDA and our fixed drives become SDB. So the reality is we shouldn't be using these kernel names within our FSTab files. So we can use labels if our file systems have labels, but more easily we can use the UUID. Within our FSTab, then referring to the UUID, then this should be part of our consistent device naming strategy. To be able to extract the UUID from a file system, we can use the command block ID. So we could use the command block ID against SDB1, and we would get the block ID, we'd have the label, we'd have the file system type. So let's take a look at using this within our CentOS 7 system. So we're working at the command line of the CentOS 7 machine. If we use first of all the ls block command, we can see then that we've got two disk devices, SDA and SDB. SR0 is our CD-ROM. When we look at SDA, we've got a couple of partitions, and then we can see that we've further gone and created some logical volumes on SDA2. On SDB1, we just have or SDB rather, we just have the one partition, and that's been formatted up with the ext4 file system. So of course this needs to be mounted somewhere. If we use the block ID command, if I just use it without any arguments, it will look then at all of the file systems that we can see, and the UUID that it gives is the UUID for the file system. So as we go through and look at SDB1, then the UUID at the moment is B4918, etc. But the unique identifier is to do with the file system. So if I go through and reformat it, we're going to see that that does change. So I can just go through. I don't have any data, so of course if you've got data, don't destroy your own file systems. But if I go through now and then we go through and format this again, there is no data on SDB1, so I'm quite happy to reformat it. Now as we go through and look at the block ID command, we can see now that we've got a completely different UUID now than the one that we had before. It now starts BA9 rather than what it was starting with before. So you can see the unique identifier is associated with the file system itself. And of course we're not normally going to change the file system, reformat a disk or partition, because of course we're going to lose all of our data. So we could just simply paste this information into our FSTab file, or we could use something like vi and read in this data for us. So if we go through now and vi/etc/fstab, when we look at the existing FSTab, then it's using the UUID for the boot file system, but it's not using it then for our root file system, in the same way with swap. The reality is there's no reason why we shouldn't use the UUID for everything, but I suppose using our logical volume names, we know that they are going to be unique. So I can use capital G or uppercase G to take me to the end of the file, and then I'm just going to hit my escape and colon and R to read in information. I'm going to read in the information from the output of the block ID command, but just against /dev/sdb1. So we can see in the bottom right hand corner of the command that I'm going to issue, and then we read in that information. I can jump across and then clear this information, so we can then go through and delete all of this and move through to the end of the line, and then we can delete this. So all of that saying that's now our device that we want to mount. We want to mount it through to the data directory. We're going to be using the ext4 file system. We'll just use the defaults. We won't allow for the dump file system, and we'll do a check after the root file system. So once we've saved that, we can then go through and take a look. Currently, the file system is not mounted, so running the mount command, I don't get anything for data. It will be clearer if I send the output through to grep and search for the word data, and we can see that it doesn't show. So then use mount -a, return to our mount command, and now we can see that data is in fact accessed now by the device /dev/sdb1. But the idea of using the UUID is that even if this changes because of the way the detection runs, we in the fstab file are using the unique identifier, so it will then just continue to work with whatever partition is currently being used. So hopefully this gives you an idea of how we can return the UUID for a file system using the commands that we've seen with block ID, and how we can then mount a file system using the UUID within the fstab. Let's return now back to the slide so we can just tidy up this section.